Okay, we're going to talk about a double pole, double throw switch and how we wire it for a lot of different things we do here. Okay? This is a double pole, double throw switch. This one happens to be a momentary double pole, double throw. And how this works is if you think of a toggle switch, that's our toggle switch. Okay? On the toggle switch, normally you have one post. If we put power to that post, when you push the switch down, let's say there's a tab here on the back of the switch. By pushing the switch down, inside here it makes a connection to allow power to flow through the switch and out to a light or whatever it is. That's how a normal toggle switch would work. You push down on it, it makes a connection here and causes the power to run through it. Okay? That would be called a single pole, single throw switch. A single pole, double throw switch would have a post down here as well. It would have 3 posts on it, and the switch would go in the up position or the down position. So a double throw means it goes up or it goes down, double. You have 2 different ways. Power comes in usually on the center post, and when you push the switch in one direction, it sends power out that side. When you push the switch in the other direction, it sends power out the other side. Okay? That all makes sense?
Yep.
That's a single pole double throw switch. If you had 2 of these switches, okay, with 3 posts on the back, you could wire something up that would go in either, that you could basically take your power wire, hook them together, and when you push this switch down, if you were to put these side by side, when you pushed them both down, you would get power out of this wire and this wire, and when you pulled them both up, you would get power out of this wire and this wire. Does that make sense?
Yes.
If you were to put those all into one switch, you would have what we have here in my hand, okay? A dual pole, dual throw switch. If you were to, in theory, cut this switch in half right here, you could divide that, and these 3 posts and these 3 posts never connect to each other. So they act as 2 separate switches that are just tied together with the same handle. Okay? Does that make sense?
Yep.
All right, so if we have a circuit, in this particular case, I'm going to talk about something different first because that's what this video should be about. Then I'll talk about what we're talking about here. Okay? This is the back of a switch. It's going to have 6 terminals on it. We're calling this a dual pole, dual pole, dual throw. Okay? That's how they abbreviate it when you order these switches. Dual pole, dual throw switch. So when we look at this and we have 6 terminals on it, just like this one has. These terminals are facing that way for whatever reason. Okay? You could draw an imaginary line right down through here. Never does this post connect to this one, or this one to this one, or this one to that one. Never does anything connect across the center line. This acts as one switch. This acts as a completely separate, independent second switch. Make sense?
Mm-hmm.
We have linear actuators. A linear actuator is a device that we use for the North Star heads to be swung in and out and to go up and down. Okay? What a linear actuator is an electric motor that has a gear on it that hooks to a gear on a shaft. And when this electric motor spins in one direction, it pushes this arm out, and when it spins in the other direction, it pulls this arm in. Okay? There's 2 wires that come off from this electric motor. If you hook this one to positive and this one to negative, the motor spins in one direction and the linear actuator goes out. If you swap this and put positive on the negative lead and negative on the positive lead, the motor spins in the opposite direction and it draws the actuator in. Simple?
Mm-hmm.
Make sense? Okay, now, If I were to take this positive and negative on just a battery, I'm going to put a battery over here, positive, negative, all right? If I take this battery and I run it to here, and I take the negative and run it to here, okay? And I take these two wires and I run them here, okay? When I push down on the toggle switch and I connect this to this and that to that, that will cause negative to carry through here, right? And positive to carry through here. Does that make sense?
Mm-hmm. Mm-hmm.
So when I push, let's say we're going to push down on this switch. If this is the switch, when I push down on this switch, it's going to cause my negative terminal here and my positive terminal here to be just straight connected to there.
Right.
Okay? And it's going to cause that power to run out to each side. You with me?
Mm-hmm.
Okay. What's going to happen down here? Nothing at all.
Not yet.
Nothing is connected at all. Okay? If I take a jumper wire, let's say I take this positive wire right here and I run it over to here, and I take the negative wire and I run it over to here, okay? When I push down on this switch and I connect here, my positive is going to run to here, and it's also going to come around to here, but is it going to do anything? This isn't hooked to anything, so it's not going to do anything
Right.
at all. Make sense?
Yes.
Same with the negative. The negative is going to run up and jump over and come to here, but it's not connected to anything, so it's going to have no impact at all. Okay? But in this particular case, what happens when I take my switch and I push it up? And now I break this connection, and now I've made this connection.
You just reversed it.
I've just reversed the polarity on these wires, and I've made this now negative and that positive. Make sense?
Mm-hmm.
And even though it back feeds over here, it doesn't matter because this isn't hooked to anything. Okay? That's a lot of wiring. So let's do this a little quicker and easier. Right on the back of the switch, let's just take a jumper wire and run it to there, and a jumper wire from here and run it to there. Okay? In other words,
Reverses it.
here's our switch, our battery. We've got a post here and a post here. I run my negative here, I run my positive here. Okay? I've got a post here, 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 and here. If I just take a little jumper wire and do this, okay, and then off from either of these posts, I run a wire out to my linear actuator, right? When I push up, I'm going to send positive and negative in one direction, and when I push down, I'm going to send it in the other direction. Does that all make sense?
Yep.
Yes.
They even make these, they make a reversing polarity switch. And when you look at a reversing polarity switch, when you look at the back of the switch, there's only 4 posts on it. Each one of these posts have a little rivet off from the side of it, so you'll see a little circle rivet. That's what holds the post to the switch. Okay? What you'll notice in this case is there'll be a rivet here and here, and there'll be a brass strap that does that, and another brass strap that's insulated so they don't touch each other, and does that. And then you have 2 posts here and 2 posts here, no posts here. That's exactly the same thing as what we just built by running a jumper wire.
Less wires, right.
Less wires. It's built to be a polarity reversing switch, okay? This is what we use on all of our spray trucks, not the reversing. At times we've bought the reversing polarity switch, but the problem is the only thing you can use that for is reversing polarity, that's it.
Right.
If you buy just a dual pole, dual throw switch, you can use it for a lot of different things, one of which is a reversing polarity, by simply running a jumper wire from here to here and from here to there, putting your positive and negative on here. Makes no difference which one's positive, which one's negative. You can switch these. Okay, all that's going to do is change which direction your switch goes to make the actuator go in or out. At the other end of these wires, we have a plug, usually right before the linear actuator. You can take those wires at the plug and turn them. Makes no difference, because all you're trying to do is put positive and negative on that actuator to make it go in or out. Okay? You guys did that the other day with
Yeah.
the boom on the top of that one truck. That was a polarity reversing mechanism.
Right.
Okay? That's how a polarity reversing switch works on our trucks. You can stop the video.